In this lesson, we're going to take a look at some applications for our exponential functions that we've been working on. There's a lot of different examples that we could choose from, but some of them would require some knowledge in some specific areas that we don't have quite yet. So I'm going to pick something that I think you've actually been exposed to a little bit last year, which is compound interest and continuously compounded interest. So we're going to be taking a look at these two formulas. The first one is the formula for regular compound interest. A equals P times parentheses 1 plus R over N raised to the NT power. And in that formula, the A is the amount of money that you're going to have in the future. The P is called your principal. That's the amount of money that you're starting with right now. R is going to be your interest rate. Now, usually your interest rates are going to be given to you as percentages. So for example, if somebody said 8%, and one of the things that's going to happen as you put this into your formula is you're going to have to convert your percentage into a decimal. So 8% is 0.08. Just move your decimal place 2 spaces to the left to convert it into a decimal. N is going to be the number of compoundings per year, and T is going to be your time measured in years for these problems. Now, let's talk about the N for a second. When we talk about the N, that is not how many months are in between or how many days are in between. This is how many times is that compounding going to happen in 1 year. So if they say, for example, the word annually, that means you're compounding only once a year. That means N is 1. If they say quarterly, that would be every 3 months, but we're not going to do 3. Quarterly means there's going to be 4 compoundings within 1 year, so N is 4. Monthly would mean N is 12. Weekly, if you didn't know this, there are 52 weeks in a year, so N would be 52 if they say weekly. For daily, we're not going to worry about leap years. We're not going to worry about the fact that there's actually like 365 and 1/4 days in a year, because every 4 years we have this extra day on February 29th. So if they say daily, we're just going to use 365. And hourly, if you multiply 24 hours in the day times 365 days in the year, that would be 8,760 hours in a year. If they're looking for some other increment, I suppose you could do that as well, but those are probably some of the major ones. Now, there is a second formula, and the second formula is called the formula for continuously compounded interest. And the continuously compounded interest formula uses our constant natural base E. You can see it right there in the formula. So although it looks like another letter in the problem, remember E has an approximate numerical value of 2.71828, 1828, and so on and so forth. So that's actually just a number. Again, the letters in this formula mean the same thing they did in our previous formula. A is the amount of money that you're going to have in the future. P is your principal amount of money. That's how much you're starting with. R is your interest rate, which of course needs to be converted from a percentage into a decimal. And T is going to be your time in years. So one of the first things that you have to decide upon as they're giving you problems involving these types of things is you have to ask yourself, am I compounding the money continuously, or am I compounding the money on some kind of a regular interval? And that will tell you which one of these formulas you're going to be using. You literally only use the second one if they actually say that the money's being compounded continuously. All right, so now let's take a look at some examples that actually make use of these compound interest formulas. And one of the things that I'm trying to show you here with this lesson is that very oftentimes the thing that we're going to be solving for might not be the thing on the left-hand side of the equation. So solving these problems may require a little bit of reorganization of your problem or coming up with creative ways to solve it, and that's what we're going to go through as we go through these variety of problems here. All right, number one, we're going to start off easy though. Number one says Jay invests $500 at 7% interest compounded annually. Find the value of the investment after 10 years. So the investment of $500 is your principal. That's the amount of money that you're starting with. 500 is P. The 7% that they're talking about is your interest rate. And of course, we're going to want to convert that into a decimal. So 0.07 is our R. Compounded annually, that is being told to you so that you know that your N value is only once a year. And oh yes, by the way, that means we're using the top formula, not the bottom formula, since our money is not getting compounded continuously. Find the value of the investment after 10 years. So our time is 10 years. And what we're missing in this problem, what they're asking you to find, is our future amount of money, A. Now, it just so happens in this problem, that means the thing we're trying to solve for is the thing that's on the left-hand side of the equation. So as we go plugging everything into the formula where it belongs, A equals our principal, which is 500, times 1 plus our interest rate, which is 0.07, over n, which is 1, raised to the nt. N is 1, t is 10. 10 times 1 is 10. This is pretty much what you want to plug into your calculator. So one of the things that you want to be careful of as you're putting this into the calculator is just to make sure that everything's going in the right spot in your calculator. So the answer to this problem, I just plugged it into my calculator and I worked it out, is $983.58. One of the things that you're going to notice that I did automatically without them even having to say it to me is I rounded my answer off to 2 decimal places. The reason why I'm going to round off to 2 decimal places every single time in this type of a problem when we're talking about money is because money can go out to the nearest cent, which is nearest hundredth. And so it was actually 983.5756786, but we're going to carry it only out to 2 decimal places. All right, let's take a look at the second problem. Problem 2A says, suppose you invest $500 at 9%. APR stands for annual percent rate, compounded monthly. Find the value of the investment after 5 years. So again, we're going to start writing down the things we know. The amount of the investment, principal, is 500. Your interest rate in this problem is 9%, which we're going to convert into a decimal. That's 0.09. And compounded monthly means that we're doing it not continuously, so that means we're using the top formula, and monthly means the end value is 12. There's going to be 12 compoundings in 1 year. This time the time is only going to be 5 years though, and they're asking us to figure out how much money will we have in the future. So again, the one thing we don't know is how much money in the future. So what is A? So we started with $500. We're getting a 9% interest rate, compounded monthly, raised to the 12 times 5. Now, when you're doing this on your calculator, if you have one of the newer calculators, if you, when you hit the caret button to raise something to a power, if your calculator shows you actually putting that in the exponential position, then you have one of the newer calculators. But if your calculator doesn't show you that, then make sure that the 12 times 5 is in its own set of parentheses so the calculator knows to multiply that first and then use 60 as the exponent. So because 12 times 5 is 60. So anyways, the correct answer to this problem right here, double check it on your own calculator, is $782.84. Okay, our next example is 2B, and it relates back to the problem that we just solved. It says, how long would it take that investment that we previously talked about to grow to $3,000? Well, previously we had said that the investment amount was $500, so P is 500. We had said that the interest rate was 9%, and we had said that it was compounded monthly. So all of these values remain from problem 2A. This question, though, does not tell us how long. That's what they're asking. And this time they're telling you what they would want for the future amount of money. They're telling you that the future amount of money needs to be $3,000. So how long is that going to take? In this problem, the time is the variable. Now, time being the variable is actually one of the hardest things to solve for in these compound interest problems. So if we look at the equation that we would set up, it's future amount of money, which we want 3,000, equals your initial investment, which is 500, times 1 plus 0.09 divided by 12 raised to the 12 times time power. The thing we're trying to solve for, time, is in the exponential position. There's only one thing in all of math that can bring exponents down out of the exponential position, and that's logarithms. But we haven't studied logarithms yet. So what we're going to do, the kind of approach that we'll take right now for a problem like this, is that we will solve it graphically. So what I'm going to do is I'm going to use my graphing calculator, and I'm going to make an equation out of the left-hand side of this. I'm going to say y1 equals 3,000, which of course is going to make a horizontal line on my graphing calculator at a y value of 3,000. And the other thing that I'm going to do is I'm going to make a second equation on my graphing calculator and say y2 equals 500 times parentheses 1 plus 0.09 divided by 12 raised to the 12t power, which is obviously going to be an exponential function that starts out at 500 and gradually increases exponentially and crosses the 3,000 line at some point. So our job now is to try to figure out exactly where does the exponential equation on the right-hand side cross the 3,000 horizontal line mark. And so when you do this, basically, you're going to have your biggest problem here is going to be to try to figure out like how far to go in the x direction to make this all work out. So what you're going to notice is if you only graph it out to 10, they haven't crossed yet. If you only graph it out to 20, they haven't crossed yet. So once you do finally have a graph that shows all of this, so the other equation that I'm drawing is 500 times 1 plus 0.09 divided by 12 raised to the 12t power. You can do second on your calculator. You can do second trace. Option number 5 to help you find a point of intersection. It's going to ask you what do you want for the first curve, what do you want for the second curve, and what do you want for an initial guess. Oh, I guess I kind of drew this wrong. That spot is happening at 19.98 years. So the amount of time that that's going to take to do this is 19.98 years. This was a graphical solution, and if you're going to do things graphically, then the graph becomes your work, and I would absolutely have to see that graph. If you magically pop out the answer of 19.98 years and you don't have a graph or any other work to show me how in the world you figured that out, I most certainly wouldn't give you full credit. So make sure that you're supporting your answers with the appropriate work that got you that answer. All right, let's take a look at example number 3. It said, how much should you invest at 8% APR, means annual percent rate, compounded daily so that the value of the investment is $5,000 after 5 years? So in this problem, the thing that we don't know is how much to start with. How much should I invest? They're asking what is P. The interest rate is 8%, which is 0.08 as a decimal. Compounded daily means that your N is 365, 65 days, 65 times it would be compounded in 1 year. So what's the they want the future value to be 5,000 after a length of 5 years. So in this problem, we know everything but how much to start out with. So we've got 5,000 equals P times 1 plus 0.08 divided by 365 raised to the 365 times 5. And again, depending on what kind of calculator you have, old or new, you may want to multiply the 5 times 365 if you have one of those older calculators first, or put parentheses around it in your exponent. If your calculator shows you the exponent, then you don't need to do that. So I'm going to go back to my regular screen. The way that you're going to solve this for P is to recognize that all of this stuff is multiplied onto the P. So basically, in order to find your answer for P, you're going to have to take 5,000 and divide it by all of this. Okay, so what I'm actually going to do here, instead of trying to do all that in one step, I'm going to figure out what 1 plus 0.08 divided by 365 is. Then I will take that decimal, 1.000219178, and I'm going to raise it to the 5 times 365 power. So this entire denominator turns into something that's approximately equal to 1.491759314, and I'm going to divide 5,000 by that previous answer. And that's going to tell me what my p-value is. Again, we're talking about money here, so automatically this should get rounded off to 2 decimal places. So we should have started with $3,351.75. Problem number 4 on this worksheet is probably one of my most favorite problems on this worksheet, because it's going to make you do something that you probably have never had an opportunity or need to do before. Number 4 says, what is the APR, compounded monthly, required for a $2,000 investment to accumulate to $4,000 in 7 years? So this time, the question is asking us, what is our interest rate? R is the thing that we don't know. We know that it's being compounded monthly, so that means N is 12. We know that we're starting with a $2,000 investment, that's our P. And we know that we want it to grow to $4,000, that's our A. and we know that it should take 7 years. That's our t. So we know every letter in this problem except for the r value. So if we go ahead and start setting up our equation, 4,000 equals 2,000 times 1 plus r, we do not know r, over 12 raised to the 12 times 7. Now, 12 times 7 is 84. If you want to solve this thing, you have to algebraically manipulate the equation to get r by itself. So the first thing that you're going to have to do on both sides of the equation is to divide by the 2,000, the number that's out in front of these parentheses, so we can get rid of it off the front of the parentheses. So you're going to have 2 equals 1 plus r over 12 raised to the 12 times 7 is 84th power. Again, if you want to get r by itself, that now means you're going to have to take an 84th root. This is something that you probably have never had the need to do. So whatever you do on one side to get rid of the 84th power on the right means you're going to have to take an 84th power on the left. When you take the 84th power of the right-hand side, the 84th power just goes away. So on my calculator, I am going to have to do the 84th root of 2. Now, the easiest way I can think of to do this on my calculator is raise 2 to the 1 over 84 power, or you could hit the math button and put in your 84th as the index and then take it on that variable index radical that they have in the math button. But I'm going to do 2 raised to the 1 divided by 84 power, because remember, radicals are just fractional exponents. The left-hand side of this is going to give me 1.008285892. And that's equal to 1 plus r over 12. So the next thing I'm going to do is subtract the 1 off of both sides. So that means the 0.008285892 is equal to r divided by 12. And then, of course, what I'm going to do next is multiply both sides by 12. And that's going to give me 0.099430703 is my r. Now remember, the interest rate right now is being given as a decimal. If you'd like to convert that back into a percentage, you're now going to have to move your decimal place 2 spaces to the right. So that means about 9.94% is what you're looking for an interest rate in order to make that happen. All right, last one, number 5. Suppose Danielle invests $1,000 at 8% APR compounded continuously. Now there's the magic word. They just said the word continuously, and that means now we're dealing with the other formula, the one that has E in it. Some people like to call this the PERT formula. Principal times E raised to the RT power is equal to how you're going to find the future amount of money. So the amount of money that she's investing is 1,000. That's your P. It's happening at 8% interest, so 0.08 is the R, and it's what her account will be worth after 5 years, so 5 years is the T. The only thing we don't know in this problem is how much money we're going to have in the future, so this is actually set up perfectly to be solved. We know everything on the right-hand side of this. So what you're going to want to do now is you're going to want to multiply 0.08 times 5. Those are the two things that are in the exponential position, which is 0.4. You're going to want to raise E to the 0.4 power. And then that's about 1.49 something. And then you're going to want to multiply that times 1,000 to get your A value. So it turns out the amount of money that Danielle will have in the future is $1,491.82. And those are some examples of how to use an application of exponential functions and how to solve not just when the thing we're looking for is on the left-hand side, but when the variable could be any part of this formula. Okay, you are now ready to try the homework for tonight that involves these compound interest formulas.